So happens to form two compounds, W and T. So we have a compound here, U, which undergoes reaction 1, which is described here as cracking. So let us write it down. This reaction here, it is cracking. And you must understand that cracking comes from, or it's an example of, elimination. And for this reaction to take place, we require high temperatures. For us to have high temperatures, which means we are referring to heat here. And we also need a catalyst. We're arguing today in class whether it is platinum or something else that we have not seen. So it is platinum. So we need a catalyst and high heat. High heat, or I don't know if high temperatures or strong heat. Sekhametsi, thank you for joining today. We appreciate you. All right. Okay, let's see. Waving at everyone. So it is cracking, which would require these two conditions here. And cracking, when it happens, it forms two types of compounds. Hey. All right. So it forms two types of compounds. These compounds may be examples, are likely to be an alkane plus an alkene. If not this one, it will be an alkene plus hydrogen. So these are the two compounds that we should think are possible for this particular reaction 1. But by look of things, we have something here. We have something here. Compound T is said to be C4H8. It follows the following pattern: CnH2n. It follows this general formula. And this general formula, therefore, it is for alkenes. So we can see that it is still within the two examples. But when we look at the other example, which is having hydrogen, will not qualify to be one of the products, because there is continuation that is happening with the other compound, W. There is continuation there. Please share the live and and keep liking as well. So W is continuing to form other products. through other types of reaction and reaction condition. Okay, fine. So that says this one cannot be. We are left with alkane plus alkene. So here we have an alkene. And I must say, if cracking happens, it means that we are talking about large alkanes. Why am I writing this S here? This S symbolizes that the compound we are dealing with, it is saturated. As long as we are talking about large compounds that are being broken down into smaller and more useful compounds, we are talking about an alkane that is big and we break it down. Sharp. Now let's look at compound T. Compound T is an alkene, and we know that our alkene is unsaturated. A compound that is unsaturated must contain one or more multiple bonds between carbon atoms. Sharp. Okay. Remember what I said. For cracking to happen, it produces, or when cracking happens, it produces an alkane and an alkene. So we have identified the alkene part. Therefore, we can talk about W, which is then an alkane. This one qualifies to be an alkane. So since it is an alkane, allow me to say that this compound, it is saturated. This compound, it is saturated. So let us look at this compound here at the bottom. CH3, CH2, 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 and Br. This is a haloalkane. So that means it's important to know the homologous series, because they can ask you to which homologous series does the compound belong. So this is a haloalkane. A haloalkane has no multiple bonds between its carbon atoms. So, which makes this I hope you are seeing that. And you must also know that all compounds that are saturated can undergo two types of reaction, which is elimination and substitution. Already we are seeing that this reaction undergoes elimination reaction. So what are we going to eliminate? We are going to remove HBr so that we can introduce the double bond. So saturated compound will undergo elimination to form an unsaturated compound. You see, I'm just using with what I have here to establish the type of compounds I have. Saturated, unsaturated, and again, unsaturated compounds unsaturated compounds, they undergo addition reaction only to form saturated compounds. Like that. So if the compound is unsaturated, it's going to undergo addition to form a saturated compound. So I think I've stated the nature of the compounds that we have, whether they're saturated, unsaturated, and so forth. Let us look at reaction number 2, because we have established reaction 1 and stated its reaction conditions. So, reaction, or rather organic compound W, undergoes reaction 2 to form that compound CH3, CH2, CH2, CH2Br. So again, let us learn. Okay, I don't know what happened there. Again, let us give the IUPAC name of this compound here. Okay, so already you'll be seeing questions now. The IUPAC name of this compound, look at our B. Our BR is in the first carbon. So we can call this compound 1 bromo butane. So it has the IUPAC name 1 bromo butane. It is also important to know how to do that before you can but sometimes you might need to draw the structure, but it's important to be able to read it as you see in a condensed form. Okay, fine. So we have that. So it's saturated. So if I'm moving from a saturated to a saturated compound, this means that this reaction, it is a substitution reaction. So the type of reaction that takes place at reaction 2 is called substitution. And again, we need to know what is it that we are substituting. So we are substituting a halogen. So which means the type of substitution here is called halogenation. And this reaction requires heat. For this reaction to take place, it requires heat. It requires heat, right? Now, you should be able to draw now the organic structure of W if needed. Now, when you eliminate, we are going to eliminate this Br and one of these. Then we are going to form this organic compound R, which is unsaturated, which is going to have an IUPAC name of 1. Okay, not 1, but 1 is still okay. So it's going to be but 1 in. So as such, this is what I have. And remember what I mentioned. Okay, so it's elimination reaction. All elimination reaction requires heat for them to take place. All of them. And I understand to be like, is it strong heat, mild, don't, and all that. You don't have to worry whether it's mild or it's strong or whatsoever it is. But just know that it's heat. So it's heat, elimination, heat, and what are we eliminating? The HBr. So we also need what we call sodium hydroxide, that is concentrated, a concentrated the strong base, concentrated strong. Any elimination, like elimination, requires concentrated stuff. And remember, we are not eliminating water here, so I wouldn't be talking about sulfuric acid. All right, so those are reaction conditions I spoke about. Then let's look at this one. Unsaturated to saturated. This makes this an addition reaction. Just that I don't know what type of addition reaction is, because I don't know what was added or what was removed. But maybe as we read questions, we'll have an idea what is happening. Then saturated to unsaturated. This is clear. This is elimination. Whatever we added, we must take it out. So somehow compound T. What happened now? Okay, my power is gone for now. Okay. How do I pause this? No, I don't want to end it. I want to pause it. Just hold on. Power is failing us. Oh. Sorry about that. There was power issues. So I went to fetch the battery just in case. Just in case. All right, I'm still here. Okay, I was still there. Okay, no, we're not. All right, I lost you there. Checking. Are we still there? The goofy. I lost you there a bit. All right, yeah, but now I'm back. All right. Um, I spoke about elimination, and we don't know what we are removing, but whatever we added, we must remove it there. Then some will be guided by the question, but you know that heat is one of the reaction. With addition, there's a lot of things to add there. There's a lot to add. Thank you, Sekhameti. Thank you, Sekhameti, for the roses and flowers. Thank you. All right, so it is important to talk to the paper before you can even engage the questions. So okay, so it's important to have your diagram look like this, or your question paper. If your question paper doesn't look like this, it means there's something that you are not doing, that you should be doing. And to do this, you are actually talking to the information. Before you can even look at the question, you realize that you have answered most of the questions. All you needed was just that guide as to say, okay, I need this, or I needed that. So let us then go through the questions. I think I've analyzed enough. I've tried my best today. I've tried my best. So, is there anything that maybe you need clarity on so that I can further elaborate on it, especially in the analysis of this flow chart? Let's hear your input or your questions or suggestions or whatever it may be. Any suggestions or input on what I've done, and maybe what's the best way you would have engaged with this flow chart of organic reactions? Okay, so since there are no inputs there, allow me to then to go through the questions and see if we have responded to these questions or not. Now, let us look at the first one. The first question is asking, what is cracking? Someone in the comment section, please help us define cracking. Someone in the comment section, help us define cracking. Someone in the comment section, help us to define cracking. Please keep sharing the live. Or reposting, something like that. So no one is there to rescue us onto that. Please rescue us. What is cracking? Right, talk to me. What is cracking? What is cracking? What is cracking? All right, since no response, I guess no one is there to rescue us onto this. All right, so cracking, we are talking about large we're talking about large hydrocarbons that will be broken down to smaller molecules and more useful. So I would say breaking down of large hydrocarbons, especially alkanes, to smaller and more useful. So this is the breaking down of large hydrocarbon, especially alkanes, to smaller and more useful molecules. And I think I did also elaborate on that to say it breaks down to alkane plus alkene and also alkene with the hydrogen. So yes, that is cracking. So it's important to know these definitions, and also it's important not to always think that definitions will be awarded 2 marks. It's not always the case. You need to know definitions. So, with that, let us look at 4.2. It says, is the product the outcome of reaction to? That scared me. The outcome of reaction to a primary, a secondary, or tertiary haloalkane. Some of you are used to seeing alcohols all the time. Haloalkane can be primary, secondary, and tertiary, depending on where they are located. So with this, let us see. I told you that this bromine here, this bromine is bonded to the first carbon. And this carbon is bonded to that carbon. And it's only one that is bonded to that. So I've realized that you can also say that since it is bonded to one other carbon, you can say that the functional group, which is C, is bonded to one other carbon. Or if you don't want to say that, you can say the carbon that is bonded to the bromine is bonded to one other carbon. Bonded to one other carbon. Yes. So the functional group, please specify what is functional group. So the functional group, which is C, Br, show that the bond lines for carbon is bonded to one other carbon, so which makes it a primary So primary, it is the answer. Primary. Sharp. Then the next question. I hope you're getting that. Then 4.3, it says write down the structural formulae of compound W. So that means now you're going back. What could it be to give us that? One thing, we know that it has 4 carbons. We know that it has 4 carbons. And we know that it is saturated. Saturated. So, but someone, can they give us the the molecular formula. Just give me the molecular formula of compound W so that I can draw the structure. Someone give us the molecular formula. Tell us how many carbons are there. Tell us how many hydrogens are there. We are talking about W. What is the molecular formula? Before we can draw the structure. Someone there to share what is the molecular formula? Give me the molecular formula of compound W. Looking at that CH3, CH2, CH2, CH2Br. What is the molecular formula of compound W before it became that? Please engage. What do you think would be the molecular formula of compound W? Just look at how the other compound is formed from W. Then you can make that conclusion. Anyone to contribute onto that? Says pentane, but pentane has 5 carbons. This one has 4 carbons. Pentane has 5 carbons, and this one has 4 carbons. So it is going to be a butane then. So what they are asking us is to draw the structural formula of butane. So this is what they are asking of us. All right, excellent. So that is the structural formula of compound W. Now it says the molecular formula of compound U. All right, to talk about molecular formula of compound W, we already know that, of U, sir. So compound W has 4 carbons. Then it's H10 plus Compound T has 4 carbons again with H8. You see that? So the total here is going to be C8H18. So the molecular formula of compound U is C8H18. This one that was broken down through cracking. I'm hoping that is making sense. Thank you, Sehametsi. I wish there was someone there to assist you in all these things. And yeah, it has been you since day one. Thank you for the contribution. We thank you. Thank you. All right. So that is the molecular formula, just for 1 mark. All right. For reaction 2. Reaction 2. They're asking, write down the name or formula of the inorganic reactant. What do we need for this substitution? Remember I mentioned that it's halogenation. So this halogenation, we already have an alkane. So we are going to substitute Br2. So because it's bromine there, although we are going to take one of them, so the answer to this, it is Br2. It's halogenation. Mr. Dunga, I see you there. Thank you for joining. Please share the link with your learners there. Hopefully they would, 1 or 2 things to pick up. So, halogenation substitution from an alkane to a haloalkane. So we are adding Br2. And of course, we are going to take 1 Br. Remember, it's substitution. So you tata 1, you nigga 1. Yeah, so, yes. Thank you, mister. Thank you. Appreciate you. Thank you. All right, so the reactant that we need is Br2. Now they are asking the type of reaction. Choose from substitution, addition, or elimination. So like I mentioned to you, remember, we have filled our basket. We have talked to the paper and we analyzed our information. Now we're just going to what we had written there and come and paste it here. So we know that it is what? Substitution. And then the question that follows says, write down 1 reaction condition. I said something to you about substitution reaction. All of them, they just require mild heat. So when I just write heat there, just write heat. It's one of the reactions. If you can remember that it's mild heat, it's okay. Continue to write. Good. So one of the reaction condition here is mild heat. But if you write heat, who knows that it is hot? Not hot. Who knows that it's strong or too hot or mild, but it's just heat. Okay. All right, so that answers those questions. Remember, all these things are just coming from what? From the analysis of the diagram. I hope you understand that. Let us now look at the next question. We are still given the same diagram. This diagram is just made for us to be easy to make reference. We're just adding in papers. Now, I'll be going back to that one. That is information, because this one, no. It's a no for me. So, because that will force us to actually go over the work again. So, we'll time to time go back to that one that we filled. For reaction 3, write down the type of elimination. I think I didn't write the type of elimination this is, but we are removing HBr, remember? So that becomes a dehydrohalogenation. Dehydrohalogenation. So this reaction is therefore a dehydro what a long name, dehydrohalogenation. And you must know that this dehydrohalogenation has 3 products: the salt plus water. Oh, thank you for the input. I thought I was alone. Because I asked for some answers there and there was some silence. Thank you for saying dehydrohalogenation. And I'm also happy that you've started with organic reactions. Please share the link, yes, for the live, and also keep liking so that we attract a large audience. Thank you, Some. So now, compounds R and T are positional isomer. They are bringing those old terminologies that you started with when you were learning this organic chemistry. And if you have forgotten them, then it becomes a problem. So here, thank you. So here, positional isomers, we need to know what that is, because as much they're talking about it, there's a chance that they would ask you to define it. They would have left out cracking and they gave you positional isomer as a definition. And this is quite long, but you must know that a positional isomer, it has the same molecular formula What is different? Someone please give us the input. What is different? What is different? So are you still there? Please help us as well. What is different? Positional isomers have same molecular formula, same number of atoms. and elements. And what is different? What is different? Same molecular formula but different what? We're talking positional isomer. Waiting for your input. What is different? What is the same is molecular formula. So what is different? There are three things. Positional isomer. Some comments. Okay, no. I don't know why there were some comments were filtered for the what. Okay. All right, it's fine. So what is different is the position of side chains that means it will be from carbon 2 to carbon 3. Position of the substituent and or the functional group. If you look at the compound in question, RNT is the one that we said is an unsaturated compound. Unsaturated compound, that's an alkene. So if that is the case, then we are talking about function. The position of the functional group is the one that is changing. On my data there, I said the IUPAC name is but1-in. So that means T can be but. You see that? So but2-in and but1-in, those are positional isomers. So that's what they are saying on this question. So fine. So we know what is a positional isomer. We know what type of position is changing or what is changing position. So maybe let me leave the definition out. Sharp. Now, the inorganic reagents. Once we talk reagents, you must know that we are referring to AMA reactants. These are reactants that they are referring to. Shown below are available for reaction 4 and 5, Roman figure. Already I'm seeing AMA red flags here. What should not be here? So what should not be here is this one. Because there's nowhere where water was added. And I don't see platinum being involved in the reaction. If you look here, there was no reaction condition of a platinum. So I'm removing that because it requires a condition. But look at these two. A reagent and that condition for elimination. You get that? When I spoke about it here, we need a concentrated sodium hydroxide, strong base for that. So already we can see that these two qualifies somehow. Br2, we have used it here for substitution purposes. But reaction 4 and reaction 5 is addition and elimination. Whatever we have added here, we must eliminate. And to eliminate, we need concentrated. So we must add something that is in the table and make use or eliminate it using the conditions that are in the table. So now they want us to write down an equation that is balanced for reaction 4 using structural formulae. Right, so which tells me that I'm going to add HBr. So here it is plus HBr. Remember, I have built one in. So I'm going to write the name for now. I have built one in plus. Or it's undergoing addition, remember? So it's going to be, what's that again? It's going to be there. It's going to be 2 bromo. But you'll be asking, how did we get to 2 bromo? 2 bromo propane. Not propane, but but. So it's addition. Oh, we're adding something here. So we're adding HBr. You see, then we have that. So we need to write a balanced equation for that. Then maybe this will also make sense why I've chosen the the 2 brom. So then plus HBr. And this will then give us so I have this number of hydrogens on the last carbon. On the first carbon here, I have 3 hydrogens. On the second, I have 2 hydrogens. And here I have 1 hydrogen. So I'm left with this bond that is not occupied. So remember, the idea is to go about bringing in the positional isomer of that other compound. So The Br will go where there are fewer hydrogens. Then we have Br. And the other hydrogen will go where there are more hydrogen. The richer get richer and the poor get poorer. Markovnikov. Right, so that is a balanced equation for 4.6.1. So that's what you must have for 5 marks. So this reaction requires a nonpolar solvent. Nonpolar solvent could be referring to something like that. And it also requires no water present. No water present. Sorry about that. All right. Anyone who's not getting this? Anyone who's not understanding what is happening here? Anyone who's not understanding? If you all understand, let's keep liking. Show with the hearts. So I guess liking shows that we do understand. But I see Sekhametsi only that is responding to it. Others show with the likes that you do understand what is happening on the screen. Show some hearts to show that you comprehending or understanding what's going on here. Thank you. Although it's Khametsi fell. But we appreciate you. We appreciate that. I hope, you are also engaging there, taking notes. Right. Now we have 4.62. Write down the balanced equation for reaction 5 using structural formula and correct reagents above. To do that again, so I'm going to remove this. Thank you for the follow. Thank you, Sekhametsi. You have been wonderful. All right. So, thank you. You're welcome too. All right. So, reaction 5. Let's go back and look at reaction 5. Remember, reaction 5, it is forming 1, 2, 3, 4 Br So this is compound S being formed here. So this compound X must now react with something, or if not even reacting, something must happen to it to form but now we're going to put in carbon number 2 because this one we put it in carbon number 1. You see, so there must be a difference. This one carbon number 1, that one carbon number 2. That makes it a positional isomer. So as that, we are going to take the product S. This is what we have, and remember we are eliminating. We are eliminating, so we are going to have what do we need for this elimination? We need sodium hydroxide, and it must be concentrated. Remember, it's elimination, this one. So when this happens, we are going to have 1, 2, 3, 4, and with the double bond. And then how do we go about choosing our double bond? According to Zaysef, we are going to take the atoms that are adjacent to each other. But mostly for major product, you are going to take where there are fewer hydrogens. So the two carbons in between have fewer hydrogen compared to the other ones. So we are going to take from there. You know, normally they say we take from the poor. Kodwa ke, it's another discussion for another day. So then we have that, we have that, and we have that, we have that, we have that. And remember, this is dehydrohalogenation as well. So this dehydrohalogenation is going to produce 3 products. So the question is, where is the Br going? Where is the hydrogen going? So when that happens, this Br is going to form a salt with Na. Then we are going to have NaBr. Then that hydrogen over there is going to now react with the OH to form what? Water. So just note, dehydrohalogenation, when it happens, it forms 3 products. It is the only one in our curriculum. It is the only one. So this is what you have for 3 marks. That is for 3 marks. Questions? Anyone who doesn't understand, if you do understand, please hit the likes there and share the link to what do you call that, to other platforms so that we can reach numbers. Thank you, Sekhametsi. Thank you. Yes. So there's another question there, 4.63, which says, give us the IUPAC name of compound T. Compound T is here. So now that you know that is a positional isomer, so the possible IUPAC name, I think I gave you there, but2-ene. So the possible IUPAC name, it is but2-ene. The possible IUPAC name of this. So 4.63. The IUPAC name is but2-ene. So I'm sure that is helpful and meaningful to have discussed this paper and this question. I can say it is taking me this long to respond to the question because here I'm trying to show you strategies or ways to engage with the question, and not just to run through the question. If I was alone, possibly I would be able to answer those questions without having to discuss. But I would really encourage you to actually talk to the paper, have a draft like this. Have a draft like this, something like that. If not something like that, then you're going to have a problem. Talk to the paper. Don't rush to answer those questions. By the time you finish analyzing the flowchart, you have answered 90% of those questions, if not 80. So please practice this. It's another type of mathematics, if I should say. This subject is so selfish, just like maths. It needs your attention, and all of it, not just half of it. It needs your attention each and every day. You need to know these reaction conditions. You need to know the reaction types, and know how to write structural formulas, know how to write molecular formulae, condensed, empirical formula, molecular formula. You know those things. All those 5 formulas, general formula as well. You really need to know that, so that, when you respond to the questions, you know what you are doing. Because we are training you to be experts of these things, so that tomorrow you can help the next person. So let us practice on a daily basis. Let's do maths, let's do physics on a daily basis. Otherwise, things will be better. And I've also realized that there is actually multiple platforms, a lot of them, where people engage with this type of work, and the whole aim is to assist you as a learner, to assist everyone that is busy with their studies, and to make the work even lighter. Although on the other note, just learn to actually study, because you also need that area to study on your own. than to be dependent on being always been given solutions or guides. So, yes, seek guidance, but also learn to be independent in terms of your studies, because you do need to be independent so that when you get to the exam, you know what to do. Unlike forgetting when you need that content the most. So engage with physical science on a daily basis. Yeah, I just wish, Sekhametsi, there was someone to assist you in terms of gifting. And yeah, because yeah, you've been wonderful since those learners encouraged me to engage with these live shows. You've been, yeah, I wish there was another you so that they can help you to do the wonderful work you are doing currently. Yeah. I hope you are seeing that, Khontle. Yes. Right. I don't have much. I just wanted to dig deep into this, and I think we can also engage onto these type of questions as of tomorrow. We're gonna start at 8 as well, and we close it at around this time. But don't forget to study. This does not, what do you call this? What do you call this? It does not eliminate studying. It's not an elimination reaction. This one is addition. It's not a substitution reaction. So I'm just adding on what you already have. Remember, you are more reactive than the alkanes. So therefore, you need to undergo addition reaction, which is what we are doing here. Trying to simplify the work, so we are adding on to you to what you have already learned. And yeah, so these are just strategies. And remember Triple S USA, that can be a short version of remembering which compounds are saturated and which ones are unsaturated, and which reaction and which reactions are taking place through those type of compounds. Thank you so much, Sekhametsi. Thank you for Ngela Mates. Thank you. Thank you. Yeah, hopefully in future we should be having someone who's going to add or assist you in what you are doing. Sekhametsi, I thank you. I thank you. So yeah, thank you so much. Thank you. Thank you so much. Khontle, are you still here? Thank you. See you tomorrow.